Hello, this time bandwidths, and we'll start at level 1 and get a few questions. Right, op-amps have a gain bandwidth product of 4 MHz, and the question is, what is the 3 dB bandwidth? Well, the formula that we need here is the fact that for a non-inverting amplifier like this one, the 3 dB bandwidth, I'll call it bandwidth 3 dB, is equal to the gain bandwidth product divided by the gain. Fairly straightforward formula for a non-inverting amplifier. So we just need to divide the gain bandwidth product by the gain. Gain bandwidth product is 4 MHz, and the gain, well, the gain of a non-inverting amplifier is 1 plus the ratio of this feedback resistor to this resistor to ground, so that would be 1 plus 3 divided by 16. Again, I'm not bothering to type the K because it would cancel out anyway and it would just slow me down. Fine. Next. Here we have a inverting amplifier, and the question that we've been asked is slightly different. By what frequency has the power gain dropped by a factor of 2? Well, the formula for a inverting amplifier like this one is slightly different. This is for a non-inverting. For an inverting amplifier, 3 dB bandwidth is the gain bandwidth product divided by 1 plus the modulus of the gain. The gain is actually negative for an inverting amplifier. And you'll note that this time we've been asked what frequency has the power gain dropped by a factor of 2. Whereas before we were asked what is the 3 dB bandwidth. And we could also be asked, and some questions do, what frequency has the voltage gain dropped by a factor of √2. And it's important to know that all of these questions are asking the same thing. They're all asking what the 3 dB bandwidth is. And yes, I know, strictly speaking, the 3 dB bandwidth and the half power bandwidth, where the power has dropped by a factor of 2, are not exactly the same thing, but they're so close together that engineers usually don't worry about the difference and just call them the same thing. Right, so we're looking for the 3 dB bandwidth, and this is the formula we need to use. So 5 MHz divided by 1 plus the gain, and the gain of an inverting amplifier is this resistor divided by this resistor. So that's 100 divided by 3. Once again, no need to type the K, it just slows you down. Let's find a different one. Here we have a differential input amplifier. And a differential input amplifier has the same bandwidth from each input. It's got to, really, otherwise it wouldn't work as a differential amplifier at higher frequencies. So we could use either of these two formulas. Gain bandwidth product, 5 MHz, divided by, well, let's look at the inverting input. It's probably the simplest one to use. From the inverting input here, the gain would be 150 divided by 82, and the formula we need to use is, this one here. So that would be 1 plus 150 divided by 82. Great. And I think there's one other type of problem. Yeah, here, a summing amplifier at level 1. Now, summing amplifiers have a slightly different formula. Summing amplifiers, the bandwidth, 3 dB, is the gain bandwidth product divided by 1 plus the sum of all the gains from all the inputs. That's what you need for a summing amplifier. And here we have a summing amplifier with a gain of 11 divided by 4K7 from this input, and 11 divided by 4K7 from this input. unity gain bandwidth is 5 megahertz, so the 3 dB bandwidth, which is the same thing as the frequency where the voltage gain drops by a factor of √2, would be 5 mega divided by 1 plus the gain from A, which is 11 divided by 4.7, plus the gain from B, which is another 11 divided by 4.7. Right, I think that's all the types of questions you get at level 1. Shouldn't be too bad.